Imagine a quiet night in the high desert of Chile, where the stars burn bright against a velvet black sky. On July 4th, 2025, a telescope called ATLAS, short for Asteroid Terrestrial Impact Last Alert System, sits atop a mountain, scanning the heavens. Its job is to hunt for asteroids that might threaten Earth. But on this night, it stumbles across something far stranger, an object hurtling through space at 137,000 miles per hour, a cosmic traveler that doesn't belong to our solar system. This is 3I ATLAS, the third interstellar object ever detected, and its arrival has sparked a question that sends shivers down the spine. Could this be more than just a rock? Could it be watching us? Before we start, let me know where you are watching this video from, and what time is it in the comments below. And while you are at it, also make sure to like and subscribe so we can bring out more videos like these. Now let's begin. The discovery of 3I ATLAS was a moment that electrified astronomers around the world. To understand why, we need to step back and picture our place in the universe. Our solar system is like a cozy neighborhood, with the sun at its center, surrounded by planets, asteroids and comets that all orbit in a predictable dance. These objects are bound by the sun's gravity, circling it like dancers tied to a maypole. But 3I ATLAS is different. It's not part of our neighborhood. It's a visitor from another star system, a wanderer that's just passing through, never to return. This makes it a rare and precious find, a cosmic postcard from a distant part of the galaxy. Let's paint a picture of what 3I ATLAS looks like. It's not a shiny spaceship or a glowing orb from a sci-fi movie. Instead, it's a massive, rocky object, roughly 7 miles wide, about the size of a small city. As it speeds toward the sun, it's cloaked in a hazy cloud of dust called a comet, and it may even sport a faint tail like a comet streaking across the sky. These features make it look like a typical comet, but its origins are anything but ordinary. Scientists estimate that 3I ATLAS could be 7 billion years old, older than our own solar system, which is about 4.6 billion years young. This means it might carry secrets from a time when our sun was just a twinkle in the universe's eye. The story of 3I ATLAS begins with its discovery by the ATLAS telescope, one of a network of robotic eyes designed to spot potential threats from space. On that fateful July night, the telescope's cameras captured a faint speck of light moving in a way that didn't match any known object in our solar system. Astronomers quickly realized this speck was following a hyperbolic orbit, a path so extreme that it could only belong to something not bound by the sun's gravity. In simpler terms, 3I ATLAS wasn't orbiting the sun like our planets or comets do. Instead, it was slingshotting through our solar system, using the sun's gravity like a cosmic catapult to propel it back into the vastness of interstellar space. To understand why this discovery caused such a stir, let's compare 3I ATLAS to its interstellar predecessors. The first was Oumuamua, spotted in 2017 by the Pan-STARRS telescope in Hawaii. Oumuamua was a peculiar object, shaped like a cigar or a flattened pancake, about 1,300 feet long. It had no coma or tail, which puzzled scientists, as most comets develop these features when they get close to the sun. Then, in 2019, came 2I Borisov, discovered by an amateur astronomer in Crimea. Unlike Oumuamua, 2I Borisov looked like a classic comet, with a bright coma and a tail of gas and dust. It was about a mile wide and clearly came from another star system, thanks to its hyperbolic orbit. 3I ATLAS, however, is in a league of its own. It's much larger than Oumuamua or 2I Borisov, with a diameter of 7 miles, big enough to dwarf most known comets in our solar system. Its speed is staggering, clocking in at 137,000 miles per hour, or about 38 miles per second. To put that in perspective, if you could drive a car that fast, you'd circle the Earth in just over 10 minutes. This incredible velocity is another clue that 3I ATLAS hails from beyond our solar system, as only an object with the momentum of an interstellar journey could move at such a clip. But what really sets 3I ATLAS apart is its brightness. When astronomers first spotted it, it was shining with a magnitude that made it visible even to smaller telescopes. This brightness comes from its coma, a cloud of dust and gas that forms when a comet's icy surface heats up near the sun, releasing particles that reflect sunlight. Early observations suggested 3I Talis has a teardrop-shaped coma, an unusual feature that caught the eye of researchers. Some even speculated that this shape could hint at something more than natural processes, perhaps a structure or design not found in typical comets. While most scientists lean toward a natural explanation, this oddity has fueled wild theories about what 3I Talis might really be. Let's take a moment to explore why an interstellar object like 3I Atlas is so exciting. Imagine you live in a small town, and one day a stranger walks through, carrying a suitcase full of artifacts from a faraway land. You'd want to know everything about them, where they came from, what their home is like, and what stories they could tell. That's what 3I Atlas is to astronomers, a visitor from another star system, potentially carrying clues about a distant part of the galaxy. Its ancient age, possibly 7 billion years, means it could have formed around a star that's long since died, or it might have drifted through the void for eons, collecting dust and scars from its cosmic journey. The idea that 3I Atlas could be more than just a rock comes from its unusual characteristics and the timing of its arrival. When Oumuamua was discovered in 2017, it sparked a global debate. Harvard astronomer Avi Loeb suggested it might be an alien probe, pointing to its strange shape and lack of a coma as evidence of something artificial. While most scientists dismissed this as far-fetched, the idea stuck in the public's imagination. Could an advanced civilization send a probe to spy on other worlds? And if so, could 3I Atlas be another such visitor, cloaked in the guise of a comet to avoid detection? This brings us to the heart of the mystery. Could 3I Atlas be watching us? The question sounds like it belongs in a science fiction novel, but it's rooted in real scientific curiosity. When astronomers study objects like 3I Atlas, they look for signs that don't fit the usual patterns of comets or asteroids. For example, does it emit radio signals like a beacon from an alien craft? Does it change course in ways that defy natural physics, as if guided by intelligence? So far, 3I Atlas shows no such signs, but its size, speed, and brightness have raised eyebrows. Some researchers, like Loeb, argue that its trajectory aligned with the plane of our solar system's planets seems too precise to be random, almost as if it were aimed at us. To understand this idea, let's dive into the dark forest hypothesis, a chilling concept from science fiction that some scientists take seriously. Imagine the universe as a dark forest, where every civilization is a hunter, hiding to avoid being noticed by others. In this scenario, an advanced alien species might send out probes disguised as natural objects, like comets, to quietly observe other worlds without revealing themselves. If 3I Atlas were such a probe, it might be gathering data about Earth, our atmosphere, our technology, even our biology, before speeding off to report back to its creators. It's a wild idea, but one that captures the imagination and keeps astronomers up at night. Of course, the scientific community is cautious about jumping to such conclusions. Most experts believe 3I Atlas is a natural object, likely a comet or asteroid ejected from its home star system billions of years ago. Its coma and possible tail suggest it's made of ice and dust, just like comets in our solar system. When it gets close to the sun, the heat causes its icy surface to vaporize, creating the glowing coma that makes it so bright. This is standard comet behavior, and there's no concrete evidence yet that 3I Atlas is anything more than a cosmic drifter. Still, the possibility of something more keeps the conversation alive. When 3I Atlas was first detected, social media platforms like X buzzed with speculation. Posts from amateur astronomers and curious onlookers shared images of the object's faint glow, while others debated whether it could be a sign of extraterrestrial intelligence. Some users pointed to its size. 7 miles wide is unusually large for an interstellar object, and wondered if it could house technology, like a massive spacecraft masquerading as a comet. Others countered that its dusty coma and tail are textbook signs of a natural body, not an alien machine. To get a sense of the excitement, picture the scene at observatories around the world on July 3rd, 2025. Astronomers huddled around computer screens, analyzing data from Atlas and other telescopes. The Minor Planet Center, which tracks objects in our solar system, quickly confirmed that 3I Atlas was interstellar, based on its orbit and speed. Within hours, observatories from Hawaii to Australia were pointing their telescopes at the object, trying to capture every detail before it moved too far away. The race was on to learn as much as possible about this fleeting visitor, which would pass closest to the Sun on October 30, 2025, before slingshotting past Jupiter in 2026 and disappearing forever. The discovery also caught the attention of space agencies like NASA and the European Space Agency. They scrambled to redirect telescopes like the Hubble Space Telescope and the James Webb Space Telescope to study 3I Atlas in detail. Early images revealed its teardrop-shaped coma, a feature that puzzled scientists. Most comets have spherical comas, so this unusual shape sparked debate. Could it be caused by the object's rotation, or was it a sign of something more complex, like a fractured surface or even an artificial structure? These questions drove astronomers to push their instruments to the limit, hoping to unlock the object's secrets. Let's take a closer look at the Atlas telescope itself, the unsung hero of this discovery. Built to detect asteroids that might collide with Earth, Atlas is a network of robotic telescopes in Chile, Hawaii, and South Africa. Its wide-field cameras scan the sky every few nights, looking for anything that moves against the backdrop of stars. When it spotted 3I Atlas, it was doing what it does best, catching the unexpected. The telescope's data showed that the object was moving too fast and on too steep a path to be part of our solar system, marking it as a true interstellar interloper. The name 3I Atlas tells its own story. The 3I stands for the third interstellar object ever discovered, following Oumuamua and Y and 2I Borisov. The Atlas part honors the telescope that found it, a nod to the technology that made this moment possible. But for many, the name carries a sense of mystery, like a code for something unknown. On platforms like X, users began calling it the Watcher, a nickname that captures the eerie possibility that this object might not just be passing through, but observing us as it goes. As news of 3I Atlas spread, it ignited the public's imagination. Documentaries, podcasts, and articles began exploring its story, each adding to the growing sense of wonder. For some, it was a reminder of how vast and unknown the universe is. For others, it was a chance to dream about contact with an alien civilization. Scientists, meanwhile, focused on the hard data, the object's size, speed, brightness, and orbit. But even they couldn't resist the allure of the bigger question, what if? To put 3I Atlas in context, let's consider what it means to be an interstellar object. Our solar system is just one of billions in the Milky Way galaxy, each with its own planets, comets, and asteroids. Over billions of years, some of these objects get flung out of their home systems, perhaps by the gravitational tug of a passing star or a collision with another body. These cosmic castaways drift through the galaxy, traveling for millions or even billions of years until they happen to pass through another star system like ours. The odds of spotting one are incredibly low, which is why 3I Atlas is only the third such object we've ever found. The rarity of interstellar objects makes 3I Atlas a once-in-a-lifetime opportunity. When Oumuamua was discovered, scientists had only a few weeks to study it before it faded from view. 2I Borisov gave them a bit more time, but its path still limited observations. 3I Atlas, with its larger size and brighter appearance, offers a better chance to gather data, but the clock is ticking. By late 2025, it will be too far from the Sun to study in detail, and by 2026, it will be beyond Jupiter, lost to the interstellar void. This fleeting visit adds urgency to the question of what 3I Atlas might be. If it's just a comet, it's a fascinating one, carrying clues about the chemistry and history of another star system. Its dust and ice could tell us about the conditions where it formed, perhaps around a star very different from our Sun. But if it's something more, an alien probe, a derelict spacecraft, or even a fragment of an ancient civilization, the stakes are even higher. Detecting such a signal would change humanity's view of the universe forever. Let's explore the science behind why 3I Atlas looks like a comet. When a comet approaches the Sun, its icy surface begins to sublime. turning directly from solid to gas. This releases dust and gas, forming a coma that can stretch thousands of miles. If enough material is released, a tail forms, pushed away from the sun by solar wind. 3I Atlas shows these features, with a coma that's been described as teardrop-shaped and a possible faint tail. These are classic signs of a comet, but they don't entirely rule out other possibilities. An artificial object could, in theory, mimic these traits to blend in. A concept straight out of science fiction, but not impossible in the realm of advanced technology. The idea of an alien probe isn't as crazy as it might sound. Scientists have long searched for signs of extraterrestrial intelligence through projects like SETI, Search for Extraterrestrial Intelligence. These efforts focus on detecting radio signals or other artificial signatures from space. So far, nothing definitive has been found, but the discovery of interstellar objects like 3I Atlas raises a new possibility. What if aliens don't broadcast signals, but instead send physical probes to explore the galaxy? Such probes could be designed to look like natural objects, making them nearly impossible to detect unless we know what to look for. This brings us back to Avi Loeb, the Harvard professor, who's become a lightning rod for these ideas. Loeb argues that we should keep an open mind about objects like 3I Atlas. In his view, the universe is old enough, 13.8 billion years, that advanced civilizations could have developed technology far beyond our own. A probe the size of a city, like 3I Atlas, might be equipped with sensors, cameras, or even artificial intelligence, quietly collecting data as it passes through our solar system. While most scientists disagree, calling the idea speculative, Loeb's arguments have sparked a broader conversation about how we search for alien life. The debate over 3I Atlas also touches on our own history of exploration. Humanity has sent probes like Voyager 1 and 2 into interstellar space, carrying messages for any civilization that might find them. If we can do it, why couldn't another species? 3I Atlas might be a relic of such an effort. A probe launched billions of years ago by a civilization long gone, or it could be actively observing us, part of a network of interstellar spies mapping the galaxy. These ideas are speculative, but they remind us how little we know about the universe and its possibilities. As we wrap up this first chapter, let's reflect on what 3I Atlas means for us. Its discovery is a reminder that the universe is vast, mysterious, and full of surprises. Whether it's a natural comet or something more, it challenges us to look up at the stars and ask big questions. Where did it come from? What has it seen in its billions of years of travel? And most tantalizingly, could it be a sign that we're not alone? As we move forward in this documentary, we'll dive deeper into the science, the speculation, and the search for answers, following 3I Atlas on its journey through our solar system, and maybe, just maybe, into the realm of the unknown. This chapter sets the stage for an epic cosmic mystery, one that blends hard science with the thrill of possibility. 3I Atlas is a stranger from the stars, and its visit is a fleeting chance to glimpse the wonders of the universe. Whether it's a dusty comet or a silent observer, it has captured our imagination and set the course for a journey of discovery. So let's keep our eyes on the sky and our minds open to the possibilities as we ask, could 3I Atlas be watching us? Picture this, a massive object 7 miles wide, hurtling through space at 137,000 miles per hour, glowing faintly in the night sky as it streaks toward the sun. This is 3I Atlas, a cosmic traveler from another star system discovered on July 1, 2025 by the Atlas telescope in Chile. In our first chapter, we introduced this mysterious visitor and the tantalizing question it raises. Could it be more than just a rock or ice? Now in chapter 2, we're diving into the science behind 3I Atlas, what it is, how it behaves, and why it's such a big deal for astronomers. We'll explore its interstellar nature, compare it to other cosmic wanderers, and uncover the tools scientists are using to unlock its secrets. Buckle up, because we're about to take a deep dive into the universe's most fascinating visitor. To understand 3I Atlas, we first need to grasp what makes an object interstellar. Our solar system is like a giant bubble, with the sun at its center, surrounded by planets, asteroids, and comets, all held together by its gravity. These objects orbit the Sun in predictable paths, like cars circling a racetrack. But 3i Atlas doesn't play by those rules. It's not bound to our Sun. Instead, it's following a hyperbolic orbit, a path so extreme that it will swing past the Sun once and then shoot back out into the vastness of space, never to return. This orbit is the first clue that 3i Atlas comes from beyond our solar system, likely born around a distant star billions of years ago. Let's break down what a hyperbolic orbit means. Imagine throwing a ball so hard that it escapes Earth's gravity and flies into space. That's what 3i Atlas is doing. But on a much grander scale, its orbit is shaped like a stretched out curve, not a closed circle or ellipse like the orbits of planets or comets in our solar system. This shape tells astronomers that 3i Atlas has enough speed and momentum to overcome the Sun's gravitational pull. In fact, it's moving at about 38 miles per second, fast enough to cover the distance from New York to Los Angeles in under a minute. This incredible speed is a hallmark of interstellar objects, which carry the momentum of their long journeys across the galaxy. To confirm 3i Atlas's interstellar status, astronomers analyzed data from the Atlas telescope and other observatories. The Atlas system, designed to spot asteroids that might threaten Earth, caught the object's faint glow on July Perth. Its motion stood out immediately. It was moving too fast and on too steep a path to belong to our solar system. Within days, the Minor Planet Center, which tracks celestial objects, officially classified it as 3i Atlas, the third interstellar object ever discovered, following Oumuamua in 2017 and 2I Borisov in 2019. This classification was based on precise measurements of its trajectory, which showed a hyperbolic excess velocity, a fancy term for it's moving way too fast to stick around. Now, let's paint a picture of 3i Atlas itself. This isn't a shiny spaceship or a glowing orb from a sci-fi movie. It's a massive rocky body, about 7 miles across, roughly the size of a small city like Manhattan. That's much larger than most comets in our solar system, which are typically a mile or two wide. As it approaches the Sun, 3i Atlas is surrounded by a hazy cloud called a coma, made of dust and gas released from its surface. Early observations also suggest it has a faint tail, a classic feature of comets caused by solar wind pushing material away from the Sun. These traits make 3i Atlas look like a comet, but its size and interstellar origin set it apart. To understand why 3i Atlas looks this way, we need to talk about what comets are. Comets are like dirty snowballs, made of ice, dust, and rocky material left over from the formation of a star system. When a comet gets close to a star like our Sun, the heat causes its ice to sublime, turn directly from solid to gas, releasing dust that forms a coma, and sometimes a tail. 3i Atlas's coma is particularly striking, described as teardrop-shaped in early images from telescopes like Hubble. This unusual shape has puzzled scientists, as most comets have spherical comas. Some think it could be due to the object's rotation or an uneven surface, while others wonder if it hints at something more unusual. Let's compare 3i Atlas to its interstellar predecessors to see what makes it unique. The first interstellar object, Oumuamua, was discovered in 2017 by the Pan-STARRS telescope in Hawaii. It was a strange beast, about 1,300 feet long, shaped like a cigar or a flattened pancake, and it had no coma or tail, which is unusual for a comet-like object. Its odd shape and behavior led some, like Harvard's Avi Loeb, to speculate it might be an alien probe, though most scientists concluded it was a natural object, possibly a fragment of a shattered planet. The second interstellar object, 2I Borisov, found in 2019 by an amateur astronomer, was more like a typical comet. About a mile wide, it had a bright coma and a long tail, confirming its icy comet-like nature. 3i Atlas stands out from both. It's much larger than Oumuamua, or 2I Borisov, with its 7-mile diameter, making it a giant among interstellar objects. Its brightness is another key difference. When it was discovered, 3i Atlas was shining brightly enough to be seen by smaller telescopes, thanks to its large coma reflecting sunlight. This brightness suggests it's releasing a lot of dust and gas, more than Oumuamua, which had none, and even 2I Borisov, the teardrop-shaped coma, adds to its mystique, raising questions about its structure and composition. Is it a solid rock with an icy coating, or something more complex? Scientists are eager to find out. One of the most exciting things about 3I Atlas is its age. Early estimates suggest it could be 7 billion years old, older than our solar system, which is about 4.6 billion years old. This makes it a time capsule from the early universe, potentially formed around a star that no longer exists. Imagine the stories it could tell, drifting through the galaxy for billions of years, passing by countless stars, maybe even witnessing the birth of new planets. Its ancient origins make it a treasure trove for scientists, who hope to analyze its composition to learn about the chemistry of distant star systems. To study 3I Atlas, astronomers are pulling out all the stops, using some of the most powerful telescopes in the world. The Hubble Space Telescope, orbiting Earth, has captured detailed images of its coma and possible tail. The James Webb Space Telescope, with its ability to peer into the infrared spectrum, is analyzing the chemical makeup of the dust and gas. 3I Atlas is releasing, on the ground. The Vera C. Rubin Observatory in Chile, with its massive 8.4-meter mirror, is tracking the object's path with unprecedented precision. These tools are helping scientists piece together a picture of what 3I Atlas is made of and where it might have come from. Let's dive into the chemistry of 3I Atlas. When a comet's ice sublimates, it releases molecules like water, carbon dioxide, and methane, which can be detected by telescopes. Early spectra from 3I Atlas show signs of water ice and silicate dust, similar to comets in our solar system. But there's a twist. Some researchers have spotted unusual spectral lines, patterns of light that suggest the presence of compounds not commonly found in our comets. These could be clues to the chemistry of the star system where 3I Atlas formed, perhaps one with different elements or conditions than our own. For example, if it contains exotic minerals or organic molecules, it could hint at the building blocks of life in another part of the galaxy. The trajectory of 3I Atlas is another key piece of the puzzle. After its discovery, astronomers calculated that it will make its closest approach to the Sun, called perihelion, on October 30, 2025, at a distance of about 0.7 astronomical units, AU, or roughly 65 million miles. That's closer than Mars, but farther than Earth's orbit. After swinging around the Sun, it will pass near Jupiter in 2026, using the planet's gravity to slingshot back into interstellar space. This brief visit gives scientists a narrow window to study it before it fades from view, making every observation critical. To track its path, astronomers use a technique called astrometry, which measures the precise position of an object in the sky over time. By combining data from multiple telescopes, they've mapped 3I Atlas's hyperbolic orbit with incredible accuracy. This orbit not only confirms its interstellar origin, but also gives clues about where it came from. Some researchers suggest it might have originated in the Oort cloud of another star, a distant shell of icy bodies similar to the one thought to surround our Sun. Others think it could be a rogue object, ejected from its home system by a catastrophic event like a stellar collision. The size of 3I Atlas is another reason it's so exciting. At 7 miles wide, it's one of the largest comets ever observed, interstellar or not. For comparison, Halley's Comet, one of the most famous in our solar system, is about 6 miles wide. This size suggests 3I Atlas has survived a long and treacherous journey through the galaxy, avoiding collisions and erosion that would break up smaller objects. Its large size also means it's releasing a huge amount of material as it nears the Sun, creating a coma that's thousands of miles across. This makes it easier to study, but also raises questions about how such a massive object was ejected from its home system. Let's talk about the coma and tail in more detail. The coma is like a glowing halo around the comet's nucleus, the solid core at its center. As 3I Atlas approaches the Sun, its ice heats up, releasing gas and dust that form this cloud. The teardrop shape of the coma, observed by Hubble, is unusual and has sparked debate. Some scientists think it's caused by the comet spinning, which stretches the coma into an elongated shape. Others suggest it could be due to jets of gas erupting from specific spots on the nucleus, creating an uneven cloud. These jets could also explain the faint tail, which trails behind the comet as solar wind pushes material away. The tail of a comet is like a cosmic windsock, pointing away from the sun because of the solar wind, a stream of charged particles emitted by the sun. Early observations of 3I Atlas's tail are still tentative, as it's faint and hard to detect, but if confirmed, the tail could provide more clues about the comet's composition. For example, a tail rich in carbon monoxide would suggest a different origin than one dominated by water vapor. Telescopes like James Webb are analyzing the tail spectrum to identify these molecules, helping scientists build a picture of what 3I Atlas is made of. One of the challenges of studying 3I Atlas is its speed. At 137,000 miles per hour, it's moving so fast that astronomers have to act quickly to capture data. Unlike comets in our solar system which return on regular orbits, 3I Atlas is a one-time visitor. Once it passes Jupiter in 2026, it will be too far away for even the most powerful telescopes to study in detail. This urgency has led to a global effort, with observatories from Chile to Hawaii coordinating observations to maximize their time with the object. Let's explore the telescopes being used to study 3I Atlas. The Atlas telescope, which discovered it, is a network of robotic scopes designed to scan the sky for moving objects. Its wide-field cameras called 3I Atlas as a faint speck, triggering follow-up observations by larger telescopes. The Hubble Space Telescope, with its sharp imaging, has provided high-resolution pictures of the coma and nucleus. The James Webb Space Telescope, launched in 2021, is using its infrared capabilities to peer through the dust and analyze the chemical makeup of the coma. The Vera C. Rubin Observatory, which began operations in 2025, is tracking the object's motion with its massive camera, capable of capturing the entire sky every few nights. These telescopes work together like a cosmic detective team, each bringing a unique skill to the table. Hubble's visible light images show the shape and structure of the coma, while James Webb's infrared data reveal the temperature and composition of the dust and gas. The Rubin Observatory's wide-field surveys help track the object's path, ensuring astronomers don't lose sight of it. Together, they're building a detailed portrait of 3I Atlas, from its size and shape to its chemical fingerprint. One of the big questions about 3I Atlas is where it came from. Interstellar objects are thought to originate in the Oort clouds of other stars, distant regions filled with icy bodies left over from the star's formation. These objects can be ejected by gravitational tugs from passing stars or planets, sending them on a journey through the galaxy. 3I Atlas's hyperbolic orbit suggests it was flung out of its home system long ago, perhaps billions of years ago. By tracing its path backward, astronomers hope to pinpoint its origin, though this is tricky since the galaxy is constantly moving, with stars shifting positions over time. Another possibility is that 3I Atlas is a rogue object, not tied to any specific star system. These objects drift through the galaxy, untethered by gravity, and occasionally pass through systems like ours. If 3I Atlas is a rogue, it could have wandered for billions of years, collecting dust and scars from cosmic radiation. Its ancient age, potentially 7 billion years, supports this idea, as it would have had plenty of time to travel across the Milky Way. The composition of 3I Atlas is another key area of study. By analyzing the light it reflects, astronomers can identify the molecules on its surface and in its coma. Early data suggest it contains water, ice, silicate dust, and possibly organic molecules, carbon-based compounds that are the building blocks of life. These findings are exciting because they suggest 3I Atlas could carry clues about the chemistry of its home star system. If it contains complex organics, it might even hint at the potential for life elsewhere in the galaxy. Let's talk about the role of spectroscopy in studying 3I Atlas. Spectroscopy is like a cosmic fingerprinting technique, where light from an object is broken into its component wavelengths to reveal what it's made of. When astronomers point a spectrograph at 3I Atlas, they see lines in the spectrum that correspond to specific molecules, like water, carbon dioxide, or methane. These lines act like a barcode, telling scientists what's present and in what quantities. The unusual spectral lines detected in 3I Atlas's coma have raised eyebrows, as they don't perfectly match the patterns of comets in our solar system. This could mean it formed under different conditions, perhaps around a star with a unique chemical makeup. The brightness of 3I Atlas is another puzzle. Its coma reflects so much sunlight that it's visible to smaller telescopes, unlike Oumuamua, which was faint and hard to spot. This brightness suggests 3I Atlas is releasing a lot of dust, possibly because of its large size or an active surface. Some scientists think it might have a highly reflective coating, like fresh ice, that makes it shine brighter than expected. Others wonder if its brightness could be due to something else, like an unusual composition, or even though unlikely, an artificial surface. While the natural explanation is favored, the brightness keeps the door open to speculation. The discovery of 3I Atlas has also sparked interest in future missions to study interstellar objects. While it's too late to launch a spacecraft to catch 3I Atlas, it's moving too fast and will soon be too far away. Some have proposed redirecting existing missions, like NASA's Juno spacecraft, to get a closer look. Juno, currently orbiting Jupiter, could theoretically adjust its path to study 3I Atlas as it passes in 2026, though this would be a long shot. Looking ahead, missions like the ESA-JAXA Comet Interceptor, set to launch in 2029, are designed to chase fast-moving objects like 3I Atlas, waiting in space to intercept them as they pass through. The study of 3I Atlas is a global effort, with astronomers from around the world sharing data and resources. Observatories in Chile, Hawaii, Australia, and Europe are all tracking the object, while space agencies like NASA and ESA coordinate observations. On platforms like X, scientists and amateurs alike are posting updates, sharing images of the comet's glow and debating its nature. This collaborative spirit reflects the excitement of the discovery, as the world comes together to study a visitor from another star. As we wrap up this chapter, let's reflect on why 3I Atlas matters. It's not just a comet, it's a messenger from another part of the galaxy, carrying clues about the universe's past. Its size, speed, and brightness make it a unique opportunity to learn about interstellar objects and the star systems they come from. The teardrop-shaped coma, the possible tail, and the hints of unusual chemistry all add to the mystery, inviting scientists to dig deeper. And while the idea of an alien probe is far-fetched, the science of 3I Atlas is thrilling enough on its own, offering a glimpse into the vast, unknown reaches of the cosmos. In the next chapter, we'll explore the controversial idea that 3I Atlas could be something more than a natural object. Could it be an alien probe sent to observe us? We'll dive into the arguments for and against this idea, meeting the scientists who dare to ask the big questions. For now, 3I Atlas remains a scientific marvel, a 7-mile-wide enigma speeding through our solar system, challenging us to understand its secrets before it disappears forever. The idea that 3I Atlas could be something other than a natural comet sounds like it belongs in a science fiction movie. After all, it looks like a comet with its dusty coma and possible tail, and it behaves like one, releasing gas as it nears the sun. But certain features, its size, speed, trajectory, and brightness, have sparked speculation that it might not be what it seems. To understand this, we need to go back to 2017, when the first interstellar object, Oumuamua, was discovered. That strange cigar-shaped object had no coma or tail, which puzzled astronomers. Avi Loeb, a Harvard professor, published a paper suggesting Oumuamua could be an alien artifact, perhaps a derelict spacecraft or probe. The scientific community largely dismissed the idea, but it ignited a global conversation about how we'd recognize an alien visitor if we saw one. On a clear night in July 2025, a faint speck of light appeared in the sky, captured by the Atlas telescope in Chile. This speck, named 3I Atlas, was no ordinary comet. It was a visitor from another star system, speeding through our solar system at 137,000 miles per hour. In the previous chapters, we introduced this cosmic traveler and explored the science behind its interstellar nature. Its 7-mile-wide body, glowing coma, and teardrop-shaped dust cloud make it a scientific marvel. But for some, 3I Atlas is more than just a rock or ice. It's a mystery that raises a thrilling question. Could this object be an alien probe sent to watch us? In this chapter, we dive into the controversial alien hypothesis, exploring why some scientists, like Harvard's Avi Loeb, think it's possible, why others call it nonsense, and what this debate means for our search for life in the universe. Fast forward to 2025, and 3I Atlas is reigniting that debate. Unlike Oumuamua, it has a coma and a possible tail, making it look more like a traditional comet, but its unusual characteristics have caught Loeb's attention again. In a paper released shortly after its discovery, Loeb and his team pointed to several oddities. Its 7-mile size is massive for an interstellar object. Its trajectory is curiously aligned with the plane of our solar system's planets, called the ecliptic plane, and its brightness suggests an unusually reflective surface. These traits, Loeb argues, could indicate something artificial, a probe disguised as a comet to blend in with the cosmic scenery. Let's unpack these arguments and see why they're so controversial. The trajectory of 3I Atlas is another point of intrigue. Most comets and asteroids in our solar system orbit in the ecliptic plane, the flat disk where the planets lie. Interstellar objects, coming from random directions in the galaxy, are expected to have orbits tilted at odd angles. But 3I Atlas's path is remarkably close to the ecliptic plane, almost as if it were aimed at our solar system. Loeb argues this alignment is too precise to be a coincidence, suggesting it could be a deliberate choice by an intelligent designer. If an alien civilization wanted to observe a star system like ours, sending a probe along the plane where planets are most likely to exist would make sense. It's like aiming for the heart of the action. First, let's talk about the size. At 7 miles wide, 3I Atlas is much larger than Oumuamua, 1,300 feet, or 2I Borisov, about 1 mile, the second interstellar object discovered in 2019. Most comets in our solar system are a few miles across, so 3I Atlas is a giant by comparison. Loeb suggests that its size could imply a purpose-built structure, like a spacecraft or a probe designed to withstand a long interstellar journey. Imagine a city-sized machine, coated in dust to look like a comet, quietly passing through our solar system. It's a wild idea, but Loeb points out that advanced civilizations could build such objects, just as we've sent probes like Voyager 1 and 2 into interstellar space. Then there's the brightness. Atlas is unusually bright for a comet, visible even to smaller telescopes. This is due to its large coma, a cloud of dust and gas that reflects sunlight. But Loeb and his team note that the brightness is higher than expected for a natural comet of its size. They speculate that it could have a highly reflective surface, perhaps made of a material like metal or a polished coating, unlike the rough, icy surfaces of most comets. While scientists agree that the brightness is likely due to a large amount of dust, the possibility of an artificial surface keeps the alien hypothesis alive in some circles. To understand why these ideas are so divisive, let's hear from the skeptics. Most astronomers argue that 3I Atlas's features can be explained by natural processes. Its coma and tail, for example, are classic signs of a comet. When a comet's ice heats up near the sun, it releases gas and dust, forming a glowing coma that can make the object appear brighter. The teardrop-shaped coma, while unusual, could be caused by the comet's rotation or uneven jets of gas erupting from its surface. As for its size, large comets aren't unheard of. Halley's Comet is about 6 miles wide, and some comets in our solar system are even bigger. The ecliptic alignment, skeptics say, could simply be a statistical fluke, not evidence of intelligent design. Karen Meach, an astronomer who studied Oumuamua and 2I Borisov, is one of the leading voices against the alien hypothesis. In interviews on platforms like X, she's called the idea nonsense, pointing out that 3I Atlas's behavior matches what we expect from a comet. Its spectrum, the light it reflects, shows signs of water, ice and silicate dust, typical of comets in our solar system. There's no evidence of radio signals, artificial materials, or course changes that would suggest a probe. Meach and others argue that jumping to extraterrestrial explanations risks overshadowing the real science, which is exciting enough. 3I Atlas is a rare chance to study a piece of another star system, But Loeb's perspective isn't just about 3I Atlas, it's about how we approach the unknown. He argues that science should be open to all possibilities, even ones that seem far-fetched. The universe is 13.8 billion years old, he says, giving plenty of time for advanced civilizations to emerge and send probes across the galaxy. Our own species has built spacecraft like Voyager, which carry messages for potential alien finders. If we can do it, why couldn't another civilization? Loeb's critics counter that extraordinary claims require extraordinary evidence, and so far, 3I Atlas shows no definitive signs of being anything but a natural object. Let's explore this idea further. The search for extraterrestrial intelligence, or SETI, has been going on for decades, listening for radio signals or other signs of alien technology. So far, nothing definitive has been found, leading to the Fermi paradox. If the universe is teeming with life, where is everybody? The dark forest hypothesis offers one answer. Aliens are out there, but they're staying quiet to avoid trouble. A probe like 3I Atlas could be part of a stealthy network designed to look natural while collecting data. Its coma and tail could be a clever disguise, mimicking a comet to avoid suspicion. While this is purely theoretical, it fuels the imagination and keeps the alien hypothesis alive. This debate brings us to a fascinating concept: the dark forest hypothesis, popularized by the science fiction novel The Dark Forest by Liu Cixin. This idea imagines the universe as a dangerous place where civilizations hide to avoid detection by hostile others. In this scenario, an advanced species might send probes disguised as comets or asteroids to quietly observe other worlds, avoiding direct contact to stay safe. If 3I Atlas was such a probe, it could be gathering data about Earth, our atmosphere, technology, or even biology, without revealing its true nature. The dark forest hypothesis is speculative, but it resonates with those who wonder why we haven't found clear signs of alien life despite the universe's vastness. To test whether 3I Atlas could be a probe, scientists look for specific signs. One is radio signals. If it's an alien craft, it might emit or receive signals to communicate with its creators. SETI researchers have pointed radio telescopes at 3I Atlas, listening for anything unusual. So far, they've detected nothing but silence, though the search continues. Another sign would be unexpected motion. Natural comets follow predictable orbits governed by gravity, but a probe might adjust its course, perhaps to get a better look at Earth or avoid detection. Astronomers are tracking 3I Atlas's path with precision, and its orbit matches what we'd expect from a natural object. No sudden turns or accelerations. Another clue could be its composition. If 3I Atlas contains materials not found in natural comets like metals or synthetic compounds, it might suggest an artificial origin. Telescopes like the James Webb Space Telescope are analyzing its spectrum, looking for unusual elements. So far, the data show water, ice, silicates, and possible organic molecules, all consistent with a comet. But some researchers, including Loeb, argue that an advanced probe could be designed to mimic these materials, blending in with the cosmic background. This cat-and-mouse game of detection makes the alien hypothesis hard to prove or disprove. Let's take a closer look at Avi Loeb's arguments. In his paper on 3I Atlas, he points to three key anomalies: the ecliptic alignment, the high brightness, and the large size. He also notes that 3I Atlas's speed, 137,000 miles per hour, is faster than most comets, suggesting it was ejected from its home system with great force. This could happen naturally, but Loeb wonders if it could indicate a propulsion system, like a solar sail or engine. He draws parallels to Oumuamua, which showed a slight acceleration that couldn't be fully explained by natural processes. While 3I Atlas hasn't shown such acceleration, Loeb argues that we should keep an open mind. The controversy over 3I Atlas has played out not just in scientific journals, but also in the public square. On platforms like X, users have been buzzing with theories. Some post images of the comet's glow, speculating that its size and brightness hint at something artificial. Others share memes, joking that it's an alien spaceship phoning home. Scientists have joined the conversation, with some debunking the alien idea and others urging caution. One ex-post from an astronomer read, "3I Atlas is a comet, not a UFO. Let's focus on the science." But the public's fascination shows how deeply the possibility of alien contact resonates. Critics counter that these anomalies have natural explanations. The ecliptic alignment, for example, could be a random quirk. The Milky Way is a chaotic place, with objects moving in all directions, so it's not impossible for an interstellar object to pass through our solar system's plane by chance. The brightness, as we've seen, is likely due to a large coma, and the size, while impressive, isn't unprecedented. As for the speed, interstellar objects are expected to move fast because they're not slowed by the sun's gravity like local comets. These explanations satisfy most scientists, but Loeb's persistence keeps the debate alive. To understand why the alien hypothesis is so appealing, let's consider humanity's own history of exploration. We've sent probes like Voyager, Pioneer, and New Horizons into space, carrying messages for any civilization that might find them. The Voyager Golden Records, launched in 1977, include sounds and images of Earth, from music to greetings in multiple languages. If we're doing this, it's reasonable to imagine another civilization doing the same. A probe the size of 3I Atlas could be packed with technology sensors, cameras, or even artificial intelligence, designed to study distant worlds like ours. But what would an alien probe look like? Science fiction often depicts spacecraft as sleek, metallic ships, but a real probe might be very different. To survive billions of years in space, it would need to be durable, perhaps coated in a layer of dust or ice to protect it from cosmic radiation and micrometeorites. It might be designed to look like a natural object, blending in to avoid detection. The dark forest hypothesis suggests that stealth would be key, as any civilization broadcasting its presence could attract unwanted attention. If 3I Atlas is a probe, its comet-like appearance could be the perfect camouflage. Let's explore the dark forest hypothesis in more detail. In Liu Cixin's novel, the universe is compared to a dark forest, where every civilization is a hunter, wary of revealing itself. Contacting another species could be dangerous, as they might be hostile or competitive. So, civilizations send out probes that observe quietly, collecting data without making a fuss. If 3I Atlas fits this model, it could be scanning Earth right now, analyzing our radio signals, atmosphere, or even our cities. When it passes the Sun on October 30, 2025, and slingshots past Jupiter in 2026, it might carry this data back to its creators or to another probe in a galactic network. To test the alien hypothesis, scientists are using every tool at their disposal. Radio telescopes, like those used by SETI, are listening for signals from 3I Atlas. Optical telescopes, like Hubble, are studying its shape and surface for anything unusual, like geometric patterns that might suggest a manufactured object. The James Webb Space Telescope is analyzing its chemical makeup, looking for anomalies that don't match natural comets. So far, all the data point to a natural origin, but the search continues, driven by the slim chance that we might find something groundbreaking. This idea ties into the broader question of why we haven't found alien life. The Fermi paradox asks why, in a universe with billions of stars and planets, we see no signs of intelligent civilizations. One answer is that they're hiding, either out of fear or caution. Another is that their technology is so advanced that we don't recognize it. A probe like 3I Atlas could be operating on principles we can't yet comprehend, using materials or signals beyond our detection capabilities. This makes the search for alien artifacts both exciting and frustrating. It's like looking for a needle in a haystack when you don't know what the needle looks like. It's July 4, 2025, and a faint, glowing speck lights up the screens at the Atlas Telescope facility in Chile. This is 3I Atlas, a 7-mile-wide interstellar visitor, speeding through our solar system at 137,000 miles per hour. In previous chapters, we've explored its discovery, its scientific significance as a comet from another star system, and the provocative idea that it could be an alien probe. Now in Chapter 4, we join the astronomers racing against time to study 3I Atlas before it vanishes into the interstellar void. with its closest approach to the Sun on October 30, 2025, and a final pass near Jupiter in 2026. The clock is ticking. This chapter dives into the tools, missions, and global effort to chase clues in the cosmos, unraveling the secrets of this mysterious traveler. The discovery of 3I Atlas sent shockwaves through the astronomical community. Unlike comets or asteroids bound to our Sun, this object follows a hyperbolic orbit, meaning it's just passing through, never to return. Its speed, size, and brightness make it a rare opportunity to study a piece of another star system, possibly 7 billion years old, older than our own solar system. But studying an interstellar object isn't easy. It's moving incredibly fast, and by 2026, it will be too far away for even the most powerful telescopes to observe in detail. This urgency has sparked a global race, with scientists deploying cutting-edge technology to capture every possible clue about 3I Atlas's composition, structure, and origins. Let's start with the telescopes leading the charge. The Atlas telescope, which first spotted 3I Atlas, is part of a network designed to detect asteroids that might threaten Earth. Its wide-field cameras scan the sky every few nights, catching objects that move against the backdrop of stars. On that fateful July night, Atlas's data revealed a speck moving too fast and on too steep a path to belong to our solar system. Within hours, astronomers confirmed it was interstellar, triggering a cascade of follow-up observations from observatories around the world. Atlas's role didn't end with the discovery. It continues to track 3I Atlas, providing updates on its position as it hurtles toward the Sun. One of the heavy hitters in this effort is the Hubble Space Telescope, orbiting Earth 340 miles above the surface. Hubble's sharp imaging has captured stunning pictures of 3I Atlas's teardrop-shaped coma, the hazy cloud of dust and gas surrounding its 7-mile-wide nucleus. These images show a glowing, elongated cloud. Unlike the spherical comas of most comets, astronomers are studying this shape to understand whether it's caused by the object's rotation, uneven gas jets, or something else entirely. Hubble's visible light observations are critical for mapping the coma's structure and tracking changes as 3I Atlas nears the Sun, where solar heat intensifies its activity. Then there's the James Webb Space Telescope, JWST, launched in 2021 and positioned 1 million miles from Earth. JWST is a game-changer, with its ability to see in the infrared spectrum, which lets it peer through dust clouds that block visible light. For 3I Atlas, JWST is analyzing the chemical makeup of the coma and possible tail, looking for molecules like water, carbon dioxide, methane, and even organic compounds. Early data suggest the presence of water ice and silicate dust, but there are hints of unusual spectral lines, patterns of light that don't perfectly match known comets. These could point to a unique composition, offering clues about the star system where 3I Atlas formed billions of years ago. On the ground, the Vera C. Rubin Observatory in Chile is playing a starring role. Operational since 2025, this telescope boasts an 8.4-meter mirror and a massive digital camera, the largest ever built for astronomy. It can photograph the entire sky every few nights, making it ideal for tracking fast-moving objects like 3I Atlas. The Rubin Observatory's precise astrometry, measuring the object's position over time, has helped refine its orbit, confirming its hyperbolic path and predicting its trajectory past the Sun and Jupiter. Its wide-field view also captures the faint glow of the coma, helping scientists estimate its size and density. These telescopes work together like a cosmic orchestra, each playing a unique part. Hubble provides high-resolution images, JWST reveals chemical secrets, and Rubin tracks the big picture. Other observatories, from Hawaii's Pan-STARRS to Australia's Siding Spring, are pitching in, creating a global network of eyes on 3I Atlas. This collaboration is essential because the object's speed, 38 miles per second, gives astronomers only a short window to study it. By the time it reaches Jupiter in 2026, it will be fading from view, so every observation counts. Let's dive into what these telescopes are learning about 3I Atlas's composition. When a comet approaches the Sun, its icy surface heats up, turning ice into gas through a process called sublimation. This releases dust and gas, forming the coma and sometimes a tail. For 3I atlases, the coma is thousands of miles across, glowing brightly due to reflected sunlight. The teardrop shape, seen in Hubble images, is a puzzle. Some scientists think it's caused by the comet spinning, stretching the coma into an elongated form. Others suggest jets of gas erupting from specific spots on the nucleus, creating an uneven cloud. These jets could also explain the faint tail, which trails behind as solar wind pushes material away from the sun. Spectroscopy, the technique of analyzing light to identify molecules, is key to understanding 3I atlas's makeup. JWST's infrared spectra show water, ice, and silicate dust, common in comets, but also hints of organic molecules, carbon-based compounds that are building blocks of life. These organics are exciting because they could suggest that 3I Atlas formed in a star system with conditions suitable for life. The unusual spectral lines, though, are what keep scientists up at night. They don't perfectly match the patterns of comets in our solar system, hinting that 3I Atlas's home star had a different chemical environment. Perhaps it formed around a star richer in certain elements, or maybe it picked up exotic materials during its billions of years drifting through the galaxy. The tail of 3I Atlas is another focus of study. Though it's faint and hard to detect, comets typically have two tails, a dust tail made of fine particles and a gas tail made of ionized molecules glowing under solar radiation. Early observations suggest 3I Atlas has a dust tail, but the gas tail is less clear. If confirmed, the tail's composition could reveal more about the comet's nucleus. For example, a tail rich in carbon monoxide would suggest a different origin than one dominated by water vapor. JWST's infrared capabilities are ideal for this, as they can detect molecules that don't show up in visible light. Every new spectrum adds a piece to the puzzle, helping scientists build a picture of what 3I Atlas is made of. The trajectory of 3I Atlas is another critical area of study. After its discovery, astronomers calculated that it will reach perihelion, its closest point to the Sun, on October 30, 2025, at about 0.7 astronomical units AU, or 65 million miles. That's closer than Mars, but farther than Earth's orbit. After swinging around the Sun, it will pass near Jupiter in 2026, using the planet's gravity to slingshot back into interstellar space. This path gives scientists a tight timeline. The comet is brightest and most active near the Sun, making late 2025 the best time to study it. By 2026, as it moves past Jupiter, it will be too faint for most telescopes to observe in detail. To track this trajectory, astronomers use astrometry, measuring the object's position against the stars. The Rubin Observatory's wide-field camera excels at this, capturing 3I Atlas's motion with pinpoint accuracy. These measurements have confirmed its hyperbolic orbit, a telltale sign of its interstellar origin. By tracing its path backward, scientists hope to estimate where it came from. Though this is challenging, the Milky Way is a dynamic place, with stars moving over billions of years, so pinpointing 3I Atlas's home star is like finding a needle in a cosmic haystack. Some suggest it came from an Oort cloud-like region around another star, while others think it's a rogue object, untethered from any star system. The size of 3I Atlas, 7 miles wide, makes it a standout. Most comets in our solar system are a few miles across, and even 2I Borisov, the second interstellar object, was only about a mile wide. This large size suggests 3I Atlas is robust, able to survive the harsh conditions of interstellar space, like cosmic radiation and micrometeorite impacts. Its size also means it's releasing a huge amount of material, creating a coma that's thousands of miles across. This makes it easier to study, but raises questions about how such a massive object was ejected from its home system. Was it flung out by a gravitational tug from a passing star, or was it shattered from a larger body in a cosmic collision? The brightness of 3I Atlas is another key feature. Its coma reflects so much sunlight that it's visible to smaller telescopes, unlike Oumuamua, which was faint and hard to spot. This brightness is likely due to the large amount of dust it's releasing, but some scientists wonder if it could have a highly reflective surface, like fresh ice or an unusual mineral. The teardrop-shaped coma adds to the mystery, as it's not a common feature among comets. Hubble's images are helping scientists model the coma's structure, while JWST's data reveal the temperature and density of the dust, offering clues about the nucleus's surface. One of the most exciting aspects of studying 3I Atlas is the possibility of learning about another star system. Because it's not from our solar system, its composition could reveal the chemistry of a distant star, perhaps one that formed under different conditions than our Sun. For example, if 3I Atlas contains exotic minerals or complex organic molecules, it might suggest that its home system had the ingredients for life. This makes every observation a chance to peek into a world we'll never visit, carried to us by a 7-billion-year-old traveler. But studying 3I Lathe isn't just about telescopes, it's also about dreaming big. Some scientists have proposed bold missions to get a closer look. One idea is to redirect an existing spacecraft like NASA's Juno, which is currently orbiting Jupiter. In 2026, when 3I Lathe passes near Jupiter, Juno could theoretically adjust its trajectory to study the object up close, capturing images or even sampling its dust. However, this would be a long shot, as Juno wasn't designed for such a task, and the comet's speed makes it a challenging target. Still, the idea shows how desperate scientists are to learn more before 3I Lathe slips away. Looking to the future, missions like the ESA-JAXA Comet Interceptor, set to launch in 2029, are designed specifically for objects like 3I Atlas. The Comet Interceptor will wait in space, ready to chase a fast-moving comet or interstellar object as it passes through our solar system. Unlike 3I Atlas, which was discovered too late for a dedicated mission, future visitors could be studied up close by such a spacecraft. The interceptor will carry instruments to analyze dust, gas, and even the nucleus's surface, offering a level of detail that telescopes can't match. The discovery of 3I Atlas has added urgency to these plans, showing how rare and valuable these opportunities are. The global effort to study 3I Atlas is a testament to the power of collaboration. Observatories from Chile to Hawaii, Australia to Europe are sharing data in real time, coordinated by organizations like the International Astronomical Union. On platforms like X, astronomers post updates, sharing images of the comet's glow or graphs of its spectrum. Amateur astronomers are also getting in on the action, using backyard telescopes to capture 3I Atlas's faint light and posting their findings online. One X user, an amateur from Arizona, shared a photo of the comet, writing, "Caught 3I Atlas last night. Feels like I'm chasing a piece of the universe." This enthusiasm shows how 3I Atlas has united professionals and hobbyists in a shared quest. The data collected so far paint a fascinating picture. Hubble's images show the teardrop-shaped coma evolving as 3I Atlas approaches the Sun, with jets of gas creating ripples in the dust cloud. JWST's spectra reveal water ice, silicates, and possible organics, but those unusual spectral lines keep scientists guessing. Could they indicate a rare mineral from another star system, or are they just a quirk of the comet's composition? The Rubin Observatory's astrometry has refined the orbit, predicting exactly when and where 3I Atlas will pass the Sun and Jupiter. Each piece of data adds to the story, but the full picture is still emerging. One challenge is the comet's speed. At 137,000 miles per hour, 3I Atlas is moving so fast that telescopes must track it precisely to keep it in view. This requires sophisticated software to predict its position and adjust telescope pointing in real time. The Rubin Observatory's advanced camera is ideal for this, capturing the comet's motion against the stars. But even with these tools, the window for detailed observations is closing. By late 2025, as 3I Atlas moves away from the Sun, its coma will shrink and its brightness will fade, making it harder to study. Another challenge is the distance. At perihelion on October 30, 2025, 3I Atlas will be 65 million miles from the Sun, too far for a spacecraft to reach in time. Even ground-based telescopes struggle to resolve fine details, like the exact shape of the nucleus hidden inside the coma. Scientists are using computer models to estimate the nucleus's properties based on the coma's behavior and the tail's composition, These models suggest a rocky, icy core, but the teardrop coma hints at an irregular shape or active surface, keeping the mystery alive. The study of 3I Atlas also ties into the broader search for interstellar objects. Before Oumuamua in 2017, scientists didn't know if we'd ever detect such a visitor. Now, with 3 in less than a decade, they suspect interstellar objects pass through our solar system more often than we thought. The Rubin Observatory, with its sky-scanning power, is expected to find more in the coming years, each offering a new chance to study the galaxy. 3I Atlas is a wake-up call, showing how much we can learn from these fleeting visitors if we're ready to act. Let's consider what we hope to learn from 3I Atlas. Its composition could reveal the chemistry of its home star system, shedding light on how stars and planets form. If it contains complex organics, it might suggest that the ingredients for life are common across the galaxy. Its age, possibly 7 billion years, makes it a time capsule, carrying clues from a time before our sun was born. By studying its dust and gas, we can piece together the story of its journey, from its ejection from another star system to its arrival in ours. The possibility of an alien origin, while unlikely, hasn't been entirely ruled out. In Chapter 3, we explored Avi Loeb's hypothesis that 3I Atlas could be a probe, based on its size, brightness, and ecliptic alignment. While most scientists favor a natural explanation, they're still looking for signs of artificiality, like radio signals or unusual motion. SETI researchers are using radio telescopes to listen for any transmissions, but so far, 3I Atlas is silent. Its predictable orbit also suggests it's following the laws of gravity, not a guided path. Still, the search continues, driven by the slim chance of a historic discovery. The effort to study 3I Atlas is also a story of human ingenuity. Astronomers are pushing their instruments to the limit, from Hubble's aging but sharp optics to JWST's cutting-edge infrared sensors. Software algorithms are analyzing terabytes of data, looking for patterns that might reveal new insights. Teams work around the clock, coordinating observations across time zones to ensure no moment is wasted. On X, scientists share their excitement, with one posting, 3I Atlas is like a cosmic gift. Every image feels like unwrapping a new secret. This passion drives the mission, turning raw data into a story of cosmic exploration. As 3I Atlas nears its perihelion, the stakes get higher. The closer it gets to the sun, the more active it becomes, releasing more dust and gas that make the coma and tail brighter. This is the best time to study its composition, as the heat reveals what's hidden in the nucleus. But it's also a risky time. Some comets break apart under solar stress, and while 3I Atlas's size suggests it's sturdy, there's always a chance it could fragment. If that happens, it could reveal more about its interior, but it might also make it harder to study as it scatters into pieces. The pass near Jupiter in 2026 is another critical moment. Jupiter's gravity will accelerate 3I Atlas, slingshotting it out of the solar system. This interaction could alter its trajectory slightly, giving scientists one last chance to study its motion. Some hope to use Jupiter's magnetic field to look for subtle effects, like disturbances caused by an artificial object. Though this is a long shot, the Juno spacecraft orbiting Jupiter is a tantalizing possibility, but its fuel and instruments limit what it can do. Still, the idea of a close-up look at an interstellar object keeps the dream alive. As we wrap up this chapter, let's reflect on the adventure of chasing 3I Atlas. It's a race against time, a global effort to catch a fleeting visitor before it disappears. The telescopes, from Hubble to JWST to Rubin, are our eyes on the cosmos, revealing a 7-mile-wide enigma that's both familiar and strange. Its coma, tail, and possible organics hint at a distant star system, while its speed and trajectory remind us how vast the universe is. Whether it's a comet or something more, 3I Atlas is a call to explore, to push the boundaries of what we believe is possible. In the next chapter, we'll explore the bigger questions 3I Atlas raises. What does its visit mean for humanity's place in the universe? Could it be a sign of alien intelligence, or is it a natural wonder that still holds profound secrets? As we chase these clues in the cosmos, we're reminded that every discovery brings us closer to understanding our cosmic home, and maybe, just maybe, the others who might share it. As the faint glow of 3I Atlas streaks across the night sky, captured by telescopes from Chile to Hawaii, it carries a question that resonates far beyond its 7-mile wide body. Could this interstellar visitor, discovered on July 4, 2025, be more than a comet? In the previous chapters, we followed its journey through our solar system, explored its scientific significance, debated the controversial idea that it might be an alien probe, and joined the astronomers racing to study it before it vanishes past Jupiter in 2026. Now, in this final chapter, we step back to reflect on the bigger picture. What does 3I Atlas mean for humanity? Is it a natural wonder, a cosmic time capsule, or dare we imagine, a silent observer from another world? This chapter explores these questions, weaving together science, speculation, and the human quest to understand our place in the universe. The discovery of 3I Atlas is a moment that feels like a page torn from a science fiction novel. A massive object, hurtling through our solar system at 137,000 miles per hour, glowing with a teardrop-shaped coma. It's a visitor from another star system, possibly 7 billion years old, older than our Sun. Its fleeting visit, with a closest approach to the Sun on October 30, 2025, and a final slingshot past Jupiter in 2026, gives us only a brief window to study it. But beyond the data, its water ice, silicate dust, and hyperbolic orbit, lies a deeper question. What if this object is watching us? What if, hidden beneath its dusty exterior, is technology from an alien civilization, quietly observing Earth as it passes by? Let's start with the scientific reality. 3I Atlas looks and acts like a comet. Its coma, a hazy cloud of gas and dust, glows brightly as solar heat causes its icy surface to sublime. Its possible tail, pushed by the solar wind, points away from the Sun, just as we'd expect. Telescopes like Hubble and the James Webb Space Telescope JWST have found water ice, silicates, and hints of organic molecules in its spectrum, all consistent with comets in our solar system. Its orbit, meticulously tracked by the Vera C. Rubin Observatory, follows the predictable path of a natural object, showing no signs of artificial course corrections or radio signals. For most scientists, 3I Atlas is a natural comet, a rare and precious gift from another star system. But the idea that it could be something more, a probe, a relic, or a scout, has captured imaginations worldwide. Harvard professor Avi Loeb, whose provocative theories about Oumuamua in 2017 stirred debate, has suggested that 3I Atlas's size, brightness, and ecliptic-aligned trajectory could hint at an artificial origin. While most astronomers disagree, calling these traits explainable by natural processes, the possibility lingers like a whisper in the dark. What if 3I Atlas is a cleverly disguised probe, designed to blend in as it collects data about our planet? This question, though speculative, forces us to confront our assumptions about the universe and our place in it. To explore this what-if scenario, let's imagine 3I Atlas as an alien probe. Picture a city-sized object, coated in dust and ice to mimic a comet, packed with sensors, cameras, or even artificial intelligence. As it passes through our solar system, it could be scanning Earth's atmosphere, listening to our radio signals, or mapping our cities. Its teardrop-shaped coma might conceal advanced technology, its brightness a result of a reflective surface rather than just dust. When it swings past the Sun and Jupiter, it might transmit its findings to a distant civilization or store them for a future rendezvous with another probe in a galactic network. This idea, inspired by the dark forest hypothesis, suggests that advanced civilizations might hide their presence, using stealthy probes to observe without being noticed. The dark forest hypothesis, popularized by Liu Cixin's novel The Dark Forest, paints the universe as a place where civilizations stay silent to avoid hostile encounters. In this scenario, 3I Atlas could be a silent observer, part of a strategy to explore the galaxy without revealing its creators. If true, it would explain why we haven't found clear signs of alien life despite the universe's vastness, a puzzle known as the Fermi paradox. The paradox asks, With billions of stars and planets, where is everybody? One answer is that they're hiding, sending probes like 3i Atlas to gather data while staying in the shadows. Testing this hypothesis is no easy task. Scientists are using every tool available to look for signs of artificiality. Radio telescopes like those used by the Search for Extraterrestrial Intelligence (SET) are listening for signals from 3i Atlas. So far they've heard only silence, but the search continues, especially as the object nears perihelion on October 30, 2025, when it's most active. Optical telescopes like Hubble are studying its shape and surface for anything unusual, like geometric patterns that might suggest a manufactured object. JWST's infrared data are being scrutinized for exotic materials like metals or synthetic compounds that don't match natural comets. The Rubin Observatory's precise tracking ensures that any unexpected motion, a hallmark of a guided probe, would be noticed. Yet, all evidence points to a natural comet, leaving the alien hypothesis as a tantalizing but unproven idea. Even if 3i Atlas is a natural comet, its discovery is profound. Its 7-mile size, ancient age, and interstellar origin make it a cosmic time capsule, carrying clues about a star system far from our own. Its dust and ice could reveal the chemistry of a distant world, perhaps one with conditions suitable for life. The organic molecules hinted at in its spectrum are particularly exciting, as they're the building blocks of life as we know it. If 3i Atlas contains complex organics, it suggests that the ingredients for life might be common across the galaxy, scattered by interstellar objects like seeds on the wind. This alone makes 3i Atlas a milestone in our quest to understand the universe. The study of 3i Atlas also highlights the power of human curiosity. Astronomers worldwide are working together, sharing data from telescopes in Chile, Hawaii, Australia, and beyond. The Atlas telescope, which discovered the object, continues to track its path, while Hubble captures its glowing coma, JWST probes its chemistry, and the Rubin Observatory maps its orbit. On platforms like X, scientists and amateurs alike share their excitement, posting images of the comet's faint glow or debating its nature. One X user, an amateur astronomer, wrote, "3i Atlas feels like a message from the stars, even if it's just a rock." This global effort shows how a single discovery can unite humanity in wonder. Let's consider what we've learned so far. 3i Atlas is a massive comet, about 7 miles wide, with a teardrop-shaped coma and a possible tail. Its hyperbolic orbit confirms it's not bound to our sun, and its speed, 38 miles per second, marks it as a visitor from another star. Its spectrum shows water, ice, silicates, and hints of organics, but unusual spectral lines suggest a composition that's not quite like our comets. Its trajectory, aligned with the ecliptic plane, is statistically unusual, but not impossible. These facts paint a picture of a natural object, but they don't entirely close the door on speculation. If it were a probe, how would we know? Detecting an alien probe would require clear evidence of artificiality. Radio signals would be a strong clue, but 3i Atlas is silent. A sudden change in trajectory, defying gravitational laws, would suggest guidance, but its orbit is predictable. An unusual composition like metals or polymers might indicate technology, but the data point to ice and dust. Still, an advanced probe could be designed to mimic a comet, hiding its true nature. The dark forest hypothesis suggests that stealth would be key, making detection nearly impossible without advanced technology we don't yet have. This challenge pushes scientists to think creatively, imagining new ways to spot the unseeable. The possibility of 3i Atlas as a probe raises big questions. If it's watching us, what is it looking for? Our technology, like satellites and radio towers, our biology, like the oxygen in our atmosphere, or signs of life in our oceans. Or perhaps it's studying our sun, a typical star that might reveal patterns about the galaxy. If it's part of a network, it could be one of many probes, crisscrossing the Milky Way to map habitable worlds. The data it collects might be stored for millennia, waiting for a civilization to retrieve it, or transmitted instantly to a distant star. These ideas, while speculative, spark the imagination and remind us how little we know about the universe's possibilities. If 3i Atlas were a probe, it would also raise ethical dilemmas. Should we try to contact it, sending a signal to see if it responds? Doing so could reveal Earth's presence to an unknown civilization, which could be risky if the dark forest hypothesis is true. A hostile or competitive species might see us as a threat or an opportunity. Alternatively, we could stay silent, observing the object without interfering, preserving our anonymity. These choices touch on humanity's broader approach to the search for life. Do we shout into the cosmos, hoping for a reply, or listen quietly, learning from the shadows? The Fermi paradox looms large here. With billions of stars in the Milky Way, many with planets in the habitable zone, why haven't we found alien life? One answer is that civilizations are rare, perhaps destroyed by their own technology or natural disasters. Another is that they're common but hidden, using probes like 3i Atlas to explore without revealing themselves. A third possibility is that their technology is so advanced that we don't recognize it. Like mistaking a probe for a comet, 3i Atlas challenges us to rethink our search, pushing us to develop better tools and open our minds to the unexpected. Even if 3i Atlas is a natural comet, its impact is profound. It's only the third interstellar object we've ever detected, following Oumuamua in 2017 and 2I Borisov in 2019. Each has taught us something new. Oumuamua, with its cigar-like shape and lack of coma, showed that interstellar objects can be strange and varied. 2I Borisov, with its classic comet features, proved that some look familiar. 3i Atlas, with its massive size and teardrop coma, adds a new chapter, showing that interstellar visitors come in all forms. Together, they suggest that such objects may pass through our solar system more often than we thought, and with telescopes like the Rubin Observatory, we're likely to find more. The discovery of 3i Atlas also inspires future exploration. The ESA-JAXA Comet Interceptor, set to launch in 2029, is designed to chase fast-moving objects like 3i Atlas, waiting in space to intercept them. Unlike 3i Atlas, which was spotted too late for a dedicated mission, future visitors could be studied up close, with spacecraft analyzing their dust, gas, or even landing on their surface. Such missions could reveal details telescopes can't, like the texture of the nucleus or the exact composition of the coma. The urgency of studying 3i Atlas has accelerated these plans, showing how critical it is to be ready for the next interstellar guest. The scientific value of 3i Atlas lies in its origins. As a relic from another star system, it carries clues about a world we'll never visit. Its dust and ice could reveal the chemistry of a star that formed billions of years ago, perhaps one that's now a white dwarf or a supernova remnant. Its organic molecules hint at the possibility of life elsewhere, suggesting that the building blocks of biology are scattered across the galaxy. Its age, potentially 7 billion years, makes it a witness to the early universe, a traveler that's seen things we can only imagine. By studying it, we're reading a cosmic history book, one page at a time. The public's fascination with 3i Atlas is evident on platforms like X, where posts range from scientific updates to wild speculation. One user shared a Hubble image of the comet's coma, writing, "This could be a rock or a spaceship, but either way, it's mind-blowing." Another posted a meme of an alien waving from a comet, captioned, "3i Atlas says hi." These reactions show how the object has captured hearts and minds, blending science with wonder. Even skeptics, who dismiss the alien hypothesis, admit that 3i Atlas is a reminder of how vast and mysterious the universe is. Let's reflect on what 3i Atlas means for humanity's place in the cosmos. Whether it's a comet or a probe, it's a visitor from beyond our solar system, a reminder that we're part of a much larger story. Our sun is just one of billions of stars in the Milky Way, each with its own planets, comets, and possibilities. 3i Atlas, with its ancient origins, connects us to that broader universe, showing that objects can travel between stars, carrying the history of their homes. It's a humbling thought. We're not alone in the sense that the universe is full of material, stories, and maybe even life waiting to be discovered. The idea of 3i Atlas as a probe also touches on our dreams of exploration. humanity has sent its own probes. Voyager, Pioneer, New Horizons into interstellar space, carrying messages for any civilization that might find them. The Voyager golden records with sounds and images of Earth are our attempt to say, we're here. If 3i Atlas is a probe, it could be another civilization's version of Voyager, a messenger sent to explore or observe. This symmetry makes us wonder, are we the observers or the observed? Are we the ones sending probes or the ones being studied? The search for answers about 3i Atlas also pushes technology forward. The telescopes studying it, Hubble, JWST, Rubin, are marvels of engineering, but they're stretched to their limits by this fast-moving target. Future missions like the Comet Interceptor will need even better instruments, perhaps with AI to analyze data in real time or sensors to detect faint signals. If we want to catch a probe disguised as a comet, we'll need to think like an advanced civilization, anticipating their technology. This challenge drives innovation, from better telescopes to spacecraft that can chase interstellar objects at a moment's notice. As 3i Atlas approaches its perihelion on October 30, 2025, the world is watching. Astronomers are collecting data around the clock, knowing that this is their best chance to study the comet at its most active. The coma is at its brightest, the tail, if present, at its most visible, and the nucleus releasing clues about its makeup. But there's also a sense of urgency, as the object will soon fade from view. By 2026, when it passes Jupiter, it will be a faint speck, and by 2027, it will be lost to the interstellar void, a traveler we'll never see again. This fleeting visit makes 3i Atlas a poignant reminder of time. Its 7 billion-year journey brought it to us for just a moment, a cosmic blink. Whether it's a comet or a probe, it's a chance to learn something new about the universe, to ask questions we've never asked before. If it's a natural object, it's a piece of another star's history. If it's artificial, it's a sign that we're not alone. Either way, it's a call to keep looking, to keep exploring, to keep dreaming about what lies beyond our solar system. The legacy of 3i Atlas will outlast its visit. The data we collect, images, spectra, orbital tracks, will be studied for years, adding to our knowledge of interstellar objects. The Rubin Observatory, with its sky-scanning power, is expected to find more such visitors, each a new opportunity to learn. The Comet Interceptor mission will carry the torch, ready to chase the next interstellar guest, and the debate sparked by Avi Loeb and others will continue, pushing us to question our assumptions and consider the impossible. What does 3i Atlas mean for our future? It's a reminder that the universe is full of mysteries, waiting to be explored. It inspires us to build better tools, ask bigger questions, and imagine possibilities beyond our current understanding. If it's a comet, it's a gift from the stars, a chance to learn about the galaxy's past. If it's a probe, it's a wake-up call, urging us to look closer at the objects that pass through our skies. Either way, it's a beacon, guiding us toward a deeper connection with the cosmos. As we close this documentary, let's imagine standing under a starry sky, watching 3i Atlas's faint glow. It's a stranger from another star, a visitor that's been traveling for billions of years to reach us. Its story is still unfolding, written in the light it reflects, the dust it sheds, and the questions it raises. Whether it's a comet or something more, it reminds us that the universe is vast, beautiful, and full of secrets. So let's keep our eyes on the stars, our minds open to wonder, and our hearts ready for the next cosmic traveler. Because in the end, 3i Atlas isn't just about what it is, it's about what it inspires us to become.